Okay, we need to graph each of these linear inequalities on the same graph and then look where the solution sets intersect, where the overlap is. So graphing one of these is a two-step process. So the first step is to graph, doing the first one here, 7x plus 3y equals 21. Graph that line. That's the boundary line of the region, solution set region. So we need 2 points on the line to graph it. So the intercepts are nice in this case. If x is 0, then 3 times 7 is 21, so y is 7. And if y is 0, then 7 times 3 is 21, so x must be 3. So with those 2 points, we can graph that line. Y is 7. That's the y-intercept. And x is 3. That's the x-intercept. So this line, which will be a dashed line, goes through these 2 points. That's the first step, to graph the line. Second step is to decide which side of that line we need to shade. So we can ask, is the origin shaded? The point 0, 0. If it is, then this is the side, here's the origin. And so if it's shaded, this whole side is shaded. If it's not shaded, the other side is the shady side. We answer that question by going back to the original linear inequality, 7x plus 3y less than 21, and substitute in 0 for x and 0 for y. So the result, we'll see if it's true or false. We get that 0 is less than 21, which is true. That's the answer to our question. The origin is indeed shaded. So we shade in this side of the line, the origin side of that line. And now we have to do the same two-step process for the second of our 2 linear inequalities here. So we do the same thing again. With 3x minus 5y greater than or equal to 15 here, graph this line, equals 15. Once again, the x and y intercepts are good points to find on this line, because if x is 0, it's easy to see that negative 5 times negative 3 equals positive 15, whereas if y is 0, we have 3 times 5 to get 15, so x equals 5. So x is at negative 3 over here, the x-intercept of that line, and the y-intercept is at 5 up here. So this is a solid line because it's or equal to, we include the line itself, so we have this line. And we have to ask, again, is the origin on the shady side of this line or not? So we go back to the original inequality, 3x minus 5y bigger than or equal to 15. Substitute in x and y both equaling 0 here, and see if it's true or false. This time we end up getting that 0 is bigger than or equal to 15, which is false. So the answer to our question about the origin being shaded here is no. If the origin isn't the shady side, then it's the opposite side, which is in everything over here. And the overlap of these 2 regions becomes evident. The overlap is everything between these 2 lines off to the right, off to the left here. So this is the solution region. Keeps going forever out there. The graph of the solution set of this system of linear inequalities.